So your major axis is going to be length 2a, and your minor axis is going to have length 2b. We're either talking about a horizontal ellipse, which is what I just drew up on the board, was a horizontal ellipse. So that means that the major axis is parallel to the x-axis. And the form of that particular ellipse is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. We're talking about a vertical ellipse. The formula is x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. We could also write our circle in elliptical form, where we could have x minus h quantity squared over r squared plus y minus k quantity squared over r squared equals 1. So notice the difference between an ellipse and a circle. On an ellipse, our denominators are going to be different. On a circle, they're the same. If we set it both equal to 1, circle, it's going to be the same denominators. Ellipse, it's going to be different denominators. Notice that if we're going in the x direction, our a is going to be under the x parentheses. If we're going in the y direction, our a is going to be under the y parentheses. I didn't write this down. This means the vertical means that the major axis is parallel to the y-axis. No matter whether we're talking about a horizontal or a vertical ellipse, to find the foci, it's equal to c squared, which is equal to a squared minus b squared. So to find the distance from the center to one of your foci is your distance c, and you need to find the difference between your denominators. And then we have something called an eccentricity, and that tells us about the roundness of the ellipse. And the closer your eccentricity, or E, is to 0, the more circular the ellipse. And the formula for the eccentricity, E is equal to the distance between the center and my foci, one foci, and half. So it seems like a lot to remember. It's not as hard as it looks. So we're going to go through and do some graphing and some solving of ellipses. And the directions are going to be very similar to what you have in your book under section 7.4. So we're going to graph using the major axes, the minor axis, the center, the vertices. We're going to find our foci, and we're going to find our eccentricity E. So first example, we have x squared over 64 plus y squared over 25 equals 1. The major axis will always be the larger denominator. So your major axis will always be the larger denominator. So in this case, my larger denominator is 64. So if we look at the general form, this would be a squared. This would be our b squared. So since our major axis is under the x, that means we're going to be going parallel to the x-axis. A squared is equal to 64. Therefore, my distance A is going to be plus or minus 8. B squared is equal to 25. Therefore, B is going to be equal to plus or minus 5. Good. What's the center of my ellipse going to be? Okay, so what are we subtracting from our x and from our y? Anything? 0. Nothing. So my center of my ellipse is going to be HK. We're not subtracting anything from the x. We're not subtracting anything from the y. So my center then is going to have coordinates 0, 0. From that center, I'm going to be going plus or minus 8 in the x direction. So my vertices, remember your vertices are from the center, they're going to be a distance of a. So my center is 0, 0. I'm going in the x direction, so my vertices are going to have coordinates 8, 0 and negative 8, 0. My minor axis, I'm going to be going in the opposite direction. So notice I added 8 to my x coordinates of my center. Now I'm going to add my b to the y coordinates of my center. So I'm going to have, my b is plus or minus 5, so I'm going to have 0, 5 or 0, negative 5. Okay, so here's my center, 0, 0, my HK. From my center, I'm going to be going in the x direction, a positive 8 and a negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is one vertice. This is my vertice 8, 0. I'm going to be going in the negative direction, 8. 1, 2, 3, 4, 5, 6, 7, 8. From the center, I'm going to be going, so this is my A. Let me write that down. This is the A that we were talking about earlier. This is your A. From the center, I'm going to be going up and down, is it 5?
Yeah.
So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this distance is my B on the minor axes. So this is B. This is really all I need to graph. I can graph my ellipse now. All I need to do is connect the points as best as I can to get a nice looking football. Okay, we're still asked to find the foci and the eccentricity. So remember, our foci are found by taking c squared equal to a squared minus b squared. I don't know what c squared is, but I do know what a squared and b squared are. So a squared was what I had underneath my x, which is 64, it's the larger denominator, minus b squared, which is what I had under my y, which is the smaller denominator. And when I subtract the two of them, what do I get? 39. So my c, my distance from the center to my first foci or my second foci is going to be plus or minus 39 from the center. Be along the major axis. So square root of 39, a little bit over 6. So I'm just going to roughly sketch that in here. 1, 2, 3, 4, 5, 6. So here's my one foci, and here's my other foci, and this distance right here is the square root of 39. And that is my, and then we are also asked to find our eccentricity, and that's equal to c over a. C is the square root of 39, and a is 8. And then I should also give you the coordinates of the foci. So from the center, we're going to be going plus or minus square root of 39 along the x direction. So my coordinates for the foci are going to be negative square root of 39, 0, and positive square root of 39, 0. We're going to take x plus 3 quantity squared over 9 plus y plus 1 quantity squared over 16 equals 1. So I'm going to be parallel to which axis? The y-axis or the x-axis? I'm going to be parallel to the y-axis because it has the larger denominator. So parallel to the y-axis, this makes it a vertical ellipse because bigger diameter, bigger denominator, not diameter, denominator. What's my center going to be? Negative 3, and my k is going to be, what do you say? Negative 1. Does everybody understand that? Your a squared is always your larger denominator. So if it's a vertical parabola, it's going to be under the y's. If it's a horizontal parabola, it's going to be under the x's. Before we do any more, let's start to graph this. Because I think the visuals may be a little bit easier to see. It's easier to figure out some of these points. So my center is at negative 3, negative 1. There's my center. From my center, I'm going to be going which way to be the major axis? Up, down, or left, right? Where is my larger denominator? Under the y. So my major axis is going to be parallel to the y-axis. So from my center, I'm going to be going up or down my a value. Well, a squared is equal to 16. That means that a is going to be plus or minus 4 from the center. So from my center, I'm going to be going 1, 2, 3, up 4, or 1, 2, 3, down 4. These are my vertices. It's a little easier to figure out what your vertice coordinates are going to be once you've graphed it. So it looks like we're going to have negative 3. These are my vertices. Negative 3, 3. Or negative 3, negative 5. Okay, my b squared is my other denominator, which happens to be 9. So that means that b is going to be equal to plus or minus 3 from your center. I'll be going left and right. So I'm going to go plus 3 and minus 3. And these are going to be the endpoints of my minor axis. So the endpoints of my minor axis looks like it's going to be negative 6, negative 1, or 0, negative 1. We have enough information now. We could go ahead and graph. our ellipse by connecting the points as best we can. We were asked to find our foci, and we were also asked to find our eccentricity. So remember that your foci, c squared is equal to a squared minus b squared. It's the difference in your denominators. So c squared is going to equal 16 minus 9, which is 7. Therefore, c is going to be plus or minus the square root of 7 from your center along the major axis. So we're going to be going up a little more than 2 and a little bit more than 2 down. There's my foci. If I want the coordinates of the foci, they're going to be -3 and then -1 plus the square root of 7. So the distance from here to here, I needed to add 7. This is -1. I'm going to go up 7, square root of 7, or I'm going to go down the square root of 7. So my second point is then is going to be -3, -1, minus the square root of 7. And then last but not least is our eccentricity, which is c over a, which is the square root of 7 over 4. So example C, 16 x squared plus 25 y squared minus 32x plus 50y minus 359 equals 0. So this is what we call our general form. It's hard to graph it this way. So we're going to rewrite it in standard form. Same way that we did our circles. So the first thing I'm going to do is I'm going to get my x terms together. I'm going to get my y terms together. And I'm going to add 359 to both sides. Okay, just like when we were dealing with circles, we want to be able to complete the square on our x terms and our y terms. But to be able to complete the square, the coefficient on my squared terms has to be 1. So I need to factor out whatever the coefficient of my x squared and my y squared term is. So for my x squared, I need to factor out 16 from each of the terms. When I factor out 16, I end up with x squared, what? Minus 2x. From the y's, I need to factor out a 25. I'm left over with y squared plus 2y. Okay, now we need to complete the square on each of our x terms and our y terms. So remember, we need to take 1/2 of b, which for the x's is a -2, gives me a -1, and then I need to square it. So with my x's, I should have x squared minus 2x plus 1. For my y's, I'm going to have y squared plus 2y plus what? Plus 1. Remember, whatever I do on the left side, I need to do on the right side of my equation. Yeah, okay. So we added 1 inside the parentheses. That 1 is being multiplied times 16. So we need to add 16. And this 1 inside the y parentheses is being multiplied by 25. So we need to add 25 to the right side. Now I'm going to factor. And I'm going to have two factors that are identical. X squared minus 2x plus 1. What does that factor to? X minus 1 times x minus 1. So we're just going to write that as x minus 1 squared. My y's factor to be y plus 1 quantity squared. And then I want to combine my constants. And what do we get? 400. So we're getting close to looking like standard form. We don't need to have, we want to get rid of these coefficients. And we need to have what on the right side? 1. So what I'm going to do is I'm going to divide the right side by 400. Whatever I do to the right side, I've got to do to every term on the left side. That's 1. That's 25. This is 1. This is 16. So my standard form then is x minus 1 quantity squared over 25 plus y plus 1 quantity squared over 16 equals 1. Are we talking about a horizontal ellipse or a vertical ellipse? Horizontal, because the bigger denominator is under my x. So this is a horizontal ellipse. My center is going to have coordinates what? 1, -1. A squared is equal to 25. Therefore, A is plus or minus 5 from the center. B squared is equal to 16. Therefore, B is going to be plus or minus 4 from the center. I'm going to go ahead and start to draw it so I can figure out my vertices a little bit easier. So we have our center at 1, negative 1. There's my center. You've told me that I'm going to be going in the x direction, plus or minus 5 from the center. So here's one vertice. Here's my other vertice. So my vertices are going to have coordinates 6, negative 1, negative 4, negative 1. My minor axis, I'm going to be going up or down 4 units from my center. 1, 2, 3, 4. 1, 2, 3, 4. So they have coordinates 1, 3, or 1, negative 5. We can go ahead and draw our ellipse now. Foci you find the same way. C squared equals A squared minus B squared. 25 minus 16. C squared equals 9. Therefore, C equals plus or minus 3 along the major axis in the x direction. So plus or minus 3. These are my foci. So they're going to have coordinates 4, negative 1, and negative 3, negative 1. So what I'm going to do